Hi, welcome to my video on solve a system of equations. And the system of equations we're going to solve is at least one hyperbola, and it could be a linear or it could be an ellipse. So let's look at the first system. Notice the first equation is x squared minus y squared equals 4, so it's a hyperbola. We have x squared, y squared, 1 is plus, 1 is minus. And notice this is a linear. So let's name the first equation and the second equation. So let's write down the first equation, x minus y plus 4 equals 0. Normally, we solve the equation for y. We could solve it for x, but most teachers and students solving for y. So we move the x over, make it negative, move the 4 over, make it negative, and they multiply by -1 because that's negative. So -1 makes it positive, makes it positive, makes it positive. So now that we have the equation 2 solve for y, we'll write down equation 1, which is x squared minus y squared equals 4, and we'll sub in for y. Y equals x plus 4 squared. So we're subbing in for y. Now we'll work out the square. So we got an x squared, subtract. And again, the shortcut, fast way for squaring a binomial, square the first term. Multiply 4x double, positive 8x. Square the last term, which is 4 squared is 16. And now we'll subtract, so that's x squared. So subtracting means we're going to make it the opposite of the trinomial on the inside, so that's negative. Negative 8x minus 16 equals 4. Or that's adding on the opposite. If you put a 1 here like this, -1 times these three terms will give you the same result. The x squared cancels out, and we solve for x. 4 plus 16, negative 8x equals 20. Divide by negative 8, and we have x equals negative. 4 goes into both these as a common factor, so there's a 5 and a 2. So one value. Now that we have x is a negative 5 over 2, we'll sub x equals negative 5 over 2 into number 2. So y equals x plus 4. Y equals negative 5 over 2 plus 4. Y equals negative 5 over 2 plus 4 is 8 over 2, common denominator. So y is 3 over 2. So the intersection is x is negative 5 over 2, y is 3 over 2. And to check this, sub the point into check is we're going to sub the points into number 1. X squared minus y squared equals 4 is equation 1 right here. So I'm going to sub x is negative 5 over 2. Y is 3 over 2. And negative 5 over 2 squared is 25 over 4 minus 3 over 2 squared is 9 over 4. And the common denominator is 4, so 25 minus 9 is 16. And 4 equals 4. So the ordered pair makes this equation true because that's where we got the y value. And then we'd also verify that it made equation 1 true. So this is the solution of the linear, which is a line. We got the degree 1, y equals mx plus b. And we have a hyperbola, so 1 point in intersection. Now let's solve another one. We have, again, hyperbola because we got x squared and y squared with a minus and a plus. And so we have equation 1, and again we have equation 2. So let's take equation 2, which is 12x plus 6y equals 6. And again, I like to solve for y. Divide by 6. So y equals negative 2x plus 1. So we'll sub that into, so let's sub that into number 1. So we'll write down number 1, y minus 3 squared over 9 minus x plus 1 squared equals 1. So I can sub in for y. So negative 2x plus 1 minus 3 squared over 9 x plus 1 squared equals 1. And we simplify the bracket, so we'll get negative 2x minus 2 squared over 9. And we write down the remaining part. Now we have an option of multiplying through by 9 to get rid of the fractions. So the LCD is 9. So we have an LCD. The common denominator is 9. So we'll multiply each part of the equation by 9. There we go. The 9's cancel. So we get negative 2x squared minus 2 squared. And we get negative 9x plus 2 squared. And 1 times 9 is 9. Now, we'll do the squaring first by PEMDAS. So when we square this, again we got a binomial, so we square the first term, which is 4x being squared. Product is 4x doubled, is 8x. And we square the negative 2 to get a 4. And we'll square the next binomial, and that gives us x is being squared, x squared. Product is 1x doubled, is 2x, and 1 squared is 1, equals 9. Now we have to multiply next by PEMDAS, so we'll leave 4x squared plus 8x plus 4. Multiply by negative 9 gives us negative 9x squared minus 18x minus 9 equals 9. I didn't need the brackets here when I squared it, but I have them there. So we'll group the like terms. So we got a 4x squared minus 9x squared. We got a plus 8x minus 18x plus 4 minus 9. And bring this 9 over to make it a minus. And now we add up negative 5x squared minus 10x. And that's 18. That's a minus 14. Negative 18 and 4 is negative 14. And I have a negative a terms, so first term is negative, so I'll multiply through by negative 1. So I get a 5x squared plus 10x plus 14. Negative 1 times 0 is 0, so I have a positive. Now, to solve this, we have a quadratic, so there's 2 possible answers. So let's notice that A, B, and C, that's A, that's B, and that's C. So solving this, I can do it 2 ways. I can try the factor, or I can try to definitely use the quadratic form. Let's just try to factor it first, see if we can factor. The product is A times C, so it's a 5 times 14, so the product is 70. The sum is the B, which is in the middle, so the sum is 10. So the factors of 70 to sum up to give you 10. The product is 5 times 14 is 70, and the sum is in the middle. So the product is the factors of 70, 1 times 70. And 70 got a 10, so it's a 10 times 7. Notice that 10 got a 5, so that's 5 into 70 is 14. A 10 has a 2, so 2 into 70 is 35. We got a 14, which is we have them all. So what factors of 70 here add to give you 10? 71, 17, 19, 37. Nope. So we can't do it by product and sum because they're, so that means that the answers here are imaginary or they're irrational. So let's use the quadratic formula. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. So b is 10, so that's a negative 10, plus or minus. B is 10, A is 5, C is 14, all over 2 times A, which is 2 times 5. So it's negative 10 plus or minus. If you take your calculator and you work all this out, you get a negative 180 all over 2 times 5 is 10. Now, we know that these, because that's negative, these roots are going to imaginary. I'm going to continue to simplify this just for the sake of simplifying this, but I know right now I have imaginary roots because I have a negative underneath the root. So that means I know right now there's no solution. But let's just continue to do a little bit of extra bit of math. 180, so I know because it's negative, it has an I. Now, 180 breaks down to be, let's see, 9. I see a 9 times 20. 9, 20 is 4 times 5. So that's the square root of 9 times 4 times 5. Square root of 9 is 3. Square root of 4 is 2. So that's 6 root 5. So 6i root 5 all over 10. And so that's negative 10 divided by 10 plus or minus 6i root 5 over 10. So that's negative 1 plus or minus 3i root 5 over 5, because I simplified 6 over 10. So again, I still have the I, but I just worked this out to show you how to simplify this root here. Because it's negative as an I. That means that we have the line and hyperbola do not intersect. So there's no solution because the roots are imaginary. There's a negative underneath the root. So there's no solution to this system. They do not intersect. Okay, let's solve another system. So here now we have a third one. Notice here I have a x squared and a y squared, but they're both pluses. So this is an ellipse. And here I have an x squared and a y squared. 1 is plus and 1 is minus. This is a hyperbola. So let's take this to be equation 1 and this to be equation 2. Notice the two equations have the y squareds opposite each other. So we're going to add these up so they cancel out. And I get x plus 1 squared add on x squared equals 5. So I'm eliminating the y squareds by addition. So now I'm going to square this binomial. So this is x squared. The product doubled is 2x. The 1 squared is 1. So I have x squared, so that's a 2x squared plus 2x plus 1 minus 5 equals 0. So I have 2x squared plus 2x minus 4 equals 0. And I see 2 is a GCF, so I'll take the 2 out. X squared plus x minus 2 equals 0. Notice I have a quadratic. So if this could be factorable, let's try it. X squared is x and x. The product is negative 2, so it has to be 2 and 1. The product is negative 2, the sum is 1, so that means there's a plus 2 minus 1. Multiply 2 times negative 1, negative 2, add 2 and negative 1 is 1. So 2, we got x plus 2 equals 0, or x minus 1 equals 0. So x equals negative 2, x equals 1. The 2 is a constant, so we only look at the factors that have the x. Now we have x equals 2, so we have to go and find what the y values are. So we're going to sub x equals negative 2 into number 2. So that's x squared minus y squared equals negative 2. Number 2 is easier because you just got an x squared and a y squared. So x is negative 2, so we put negative 2 in. And now we're going to solve it for y. So that's a 4 minus y squared equals negative 2. Negative y squared is negative 2 minus 4. Negative y squared is negative 6. And got a negative, so multiply by negative 1 or divide by negative 1. Y squared is 6. So y equals plus minus the root of 6, which means that when x is negative 2, y is root 6, or when x is negative 2, y is negative root 6. So we got two values. Now let's sub x equals 1 into the same equation. So x squared minus y squared equals negative 2. X is 1, so we sub 1 into place of x. 1 minus y squared equals negative 2. Negative y squared equals negative 2 minus 1. Bring the 1 over. Negative y squared equals negative 3. Again, the y squared is negative. Multiply by negative, you get y squared is 3. So y equals plus or minus the root of negative 3. Plus or minus the root of 3, not negative 3. So that means when x is 1, y is root 3. And when x is 1, y is negative root 3. So notice there's 4 points of intersection between the hyperbola, which is this one, and this is the ellipse. So the solutions are, let's write them all down again, x and I'm just repeating the ones I got written on top. There are 4 of them. And if you take each one of these points and sub them into the first equation, you should also make them true. So these are 4 solutions. So that's solving a system of equations which has a hyperbola equation. Hyperbola in a line or hyperbola in an ellipse. And it brings us to the end. Again, if you like my video, click on the like button. If you're not a subscriber, click on the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video was of some help to you. Bye-bye.